Hello everyone, we are group 3 from class AS1202C and today we will present our project for course code PHY210, which is the Improved Smart Cooking Pan, which applies the principle of rotational mechanics and thermal physics to solve common cooking problems faced by students. Our group member consists of me, Nur Aina Safa, Nurwani Adlina, Kuroto Ainuha, Melissa Kistina, and one Nur Awatif Putri. Students often cook in hostel or rented accommodation relying on ordinary pans. These pans heat unevenly, creating hot spots that burn some part of the food while leaving others undercooked. From a physics perspective, cooking is influenced by the principle of thermal physics and heat transfer. When heat is not evenly spread across the pan, heat is lost to the surrounding and efficiency decreases. To solve this problem faced by students, we propose an improved smart cooking pan which applies concepts from thermal physics and rotational mechanics.
The first part is component of need, key needs. The primary need addressed by the improved smart cooking pan is efficient and uniform heat distribution during cooking. Uneven heating in conventional pans lead to hot spots, which cause food to burn and reduce cooking quality. Ensuring even heat flow across the pan surface improves cooking consistency and taste. Another key need is reduced cooking time. By distributing heat evenly and also efficiently, the pan allows food to cook faster, saving valuable time for students with busy schedules. Lower energy consumption is also an important requirement. Efficient heat transfer minimizes unnecessary energy loss, helping to reduce electricity or gas usage and lowering cooking costs. Finally, improved cooking safety is essential. Uniform heating reduces sudden overheating, while an insulated handle minimizes heat transfer to the user, lowering the risk of burns and kitchen accidents.
Component of need. Impact is the need is not met. If the need for uniform and efficient heat distribution is not addressed, students will continue to face multiple challenges in their daily cooking activities. Uneven heating causes certain areas of food to receive excessive heat, while other areas remain undercooked. This results in poor food quality, burnt meals, and increased food wastage, which is particularly problematic for students with limited budget. Inefficient heat distribution also leads to ineffective energy usage. When heat is concentrated only in specific region of the pan, more electricity or gas is required to achieve proper cooking. This prolonged cooking times increase energy consumption and contributes to higher monthly utility expense for students. Furthermore, uneven heating can pose safety risks. Sudden localized overheating might cause oil splashes, burn, or accidental spillage, especially when students attempt to adjust the food frequently. Over time, repeated exposure to this hazard increase the likelihood of minor kitchen accidents. In addition, inefficient cooking process force students to spend more time preparing meals. This can interfere with academic commitment, study schedules, and daily routines, reducing overall productivity. The combination of food wastage, increased energy costs, safety risks, and time inefficiency can lead to financial loss, frustration, and reduced motivation to cook. Therefore, failing to meet the need for uniform heat distribution negatively impacts safety, cost-efficient time management, and overall cooking experience. Highlighting the importance of an improved cooking pan design that apply principles of physics to solve this everyday problem. Component of approach. The unique idea behind the improved smart cooking pan is the integration of a rotating inner base that actively redistributes heat during the cooking process. Unlike conventional cooking pans, where heat remains concentrated at fixed region directly above the heat source. This innovative design introduces controller rotational motion to ensure more uniform heat distributes across the entire cooking surface. The inner base rotated at a slow and constant angular speed, Driven by a simple and efficient mechanical mechanism, this controller rotation ensures that every region of the pan comes into contact with the heat source for an equal duration over time. As a result, the formation of hot spots is significantly reduced, allowing food to cook more evenly and consistently. By applying principle of rotational mechanism, the smart pan transforms static heat exposures into dynamic heat distribution. The rotational motion spreads thermal energy more effectively, reducing temperature gradient across the pan surface. This improves overall cooking efficiency and minimizes the risk of food burning due to localized overheating. So, the rotation is carefully designed to be slow and stable, ensuring user safety and preventing food from spilling.
Smart rotating cooking pan is controlled by rotational motion, which the inner base of the pan is rotated slowly during cooking. This motion ensures that each region of the pan is exposed to the heat source for the same duration over time. This design also considered as moment of inertia because it depends on the mass distribution of the pan. By concentrating mass closer to the axis of rotation, the moment of inertia is being reduced. This also allows the pan to rotate smoothly using less torque. Furthermore, a small torque also applied to initiate and maintain smooth rotation. The system is designed to be well balanced so that the pan remains stable even when the food were added or being stirred. Thermal physics explain how heat is transferred in the cooking pan. Heat from the stove is transferred to the pan mainly through conductivity. The pan uses a multi-layer of base, and aluminum is one of the base. It was used because of the high thermal of conductivity, which allow heat to spread quickly and evenly. Besides, a stainless steel layer provides strength and durability. The rate of the heat transfer can be described using the heat conduction equation, where high thermal conductivity increases heat flow. In addition, the handle is made from a low thermal conductivity material to reduce heat transfer to the user, indirectly improving the safety. Although rotation does not produce heat, it helps thermal conduction by ensuring uniform heat exposure across the pan.
And for the next one, developing an enhanced smart cooking pan with a rotating inner base and multi-layer construction presents several key technical challenges, and one of them is safe and stable rotation mechanism. A reliable system is required to ensure the inner base rotates smoothly without wobbling. The rotation speed must be careful, controlled, and slow enough to avoid food spillage, yet sufficient to distribute heat. In addition, the bearing or low friction support must be able to operate efficiently under high cooking temperatures. Second of the technical challenge, thermal expansion control. Different materials such as aluminum and stainless steel expand at different rates when heated. The design must accommodate this thermal expansion and contraction to prevent warping, layer separation, or structural failure during use. And for the third one of the technical challenges is long-term durability. Continuous rotation combined with frequent exposure to high heat can accelerate wear on the pan base and its rotating components. Therefore, the materials and assembly methods must be robust enough to ensure long-lasting performance for everyday student use. And for the last one, cost and affordability. High-quality metals, coating, and precision bearing can significantly increase production costs. The design must strike a balance between performance, durability, and affordability to remain suitable for student budget. And for the benefits, for the first one, even cooking without burning, the rotating inner base distributes heat uniformly across the cooking surface, eliminating hot spots and reducing the risk of food burning. For the second one, time and energy efficiency. Improved heat transfer shortens cooking time and lower energy usage, which helping users save on electricity or gas while reducing cooking effort. And for the third benefit is enhanced safety. The pan features slow, controlled rotation and insulated handles, minimizing the chance of burns and accidents during operation. And for the last one, durable yet affordable. The multi-layer structure combining aluminium and stainless steel ensure long-lasting performance. At the same time, the design remains cost-effective, making it suitable for daily student use.
As a conclusion, by integrating principles of rotational motion and thermal physics, the improved smart cooking pan provides a practical, efficient, and safe solution for everyday cooking. It overcomes common issues such as uneven heating, energy waste, and safety concern, which is offering students a faster, more reliable, and user-friendly cooking experience.